Alright, let's answer this question. The internal resistance of each of the cell E1 and E2 is 2 ohms. Calculate the total current in the circuit. Okay, so you can pause the video and see if you can solve this on your own, and then see if you get the same answer. Right, let's get on to it. So we have been told that the internal resistance of each of these cell E1 and E2 is 2 ohms each. That means here is 2 ohms and here is also 2 ohms. That's small letter r. Internal small letter r1 and small letter r2. So now we have to calculate the total current in the circuit. That's the current read by this ammeter here. And we're having external resistance 4 ohms. So let's get on with it. So first, according to our law, when cells are connected in parallel, their equivalent EMF will be the same. That means at this terminal here, this junction here, the voltage will be what? 2 volts. And of course, since the two cells are 2 volts and of the same polarity, at this terminal here, what it will be measured is what? 2 volts with respect to this side. So cells that are connected in parallel, the equivalent voltage will be as same as individual voltage. That's each branch will have the same voltage. All right, that is what E1 will be equals to E2 will also be equals to what? E equivalent. So let's get on with that. So I can redraw this whole thing if I want, but I may not. So what about the equivalent resistance? The equivalent internal resistance. The internal resistance in this case is a parallel connection. So for parallel connection, we have 1 over R equivalent to be what? 1 over R1 plus 1 over R2. Since both of them are the same, 1 over R equivalent will be what? 1 over 2 plus 1 over 2, which equals to what? 1 ohms. So if you have 1 over R equivalent equals to 1 ohm, you take reciprocal of that, you find out that your R, small letter r equivalent, the summation of the internal resistance will be 1 ohm. So having figured out the internal resistance to be 1 ohm, then we continue. You remember that EMF equals to what? Total current in the circuit times external resistance plus internal resistance. This time around, internal resistance will be the equivalent one. And we are looking for this current I. If you make that the subject of the formula, have that I equals to E divided by what? External resistance plus equivalent internal resistance, which equals to our E here, EMF will be 2 volts, since it will measure the same voltage. 2, our external resistance is 4. 2 divided by 4 plus our equivalent internal resistance is 1. So this will be 2 divided by 5. Okay, 2 divided by 5 will be 0.4 amps. So the answer to that is 0.4 amps.